This is lesson 1, an introduction to electromagnetism for year 13 physics. I'll just rub the date off. Okay, so electromagnetism is a study of the relationship between electric currents and magnetic fields. Now, where do we have magnetic fields? You do have a magnetic field around a bar magnet, and what we need to make sure is that field lines leave the North Pole, enter the South Pole, and it's most concentrated at the poles. Now, what is a magnetic field? It's the area around a magnet where another magnet or a magnetic object would feel a force, and your magnetic objects are iron, cobalt, and nickel. You'll also find a magnetic field around a current carrying wire, and the shape of the field is circular, and that is the formula for the magnetic field strength, and this is what the letters all stand for. Now, the further away you are from the wire, the weaker the magnetic field, and the spacing of the field lines is an indication of the strength of the magnetic field. So closer the lines, stronger the field. You also have a magnetic field in and also around a solenoid. Now, the field lines are parallel straight lines and they're evenly spaced inside the solenoid. This tells us that the magnetic field inside the solenoid is uniform, and this is the formula for the magnetic field inside the solenoid. Now, there are two places where you have a uniform magnetic field. One is between the poles of a magnet, and the other one is inside a solenoid. Okay. Now, there's a term called magnetic flux, and which is measured in Webers, and it is the amount of magnetic field in a certain area. And the magnetic flux is represented by lines of flux. Now, rearranging this equation, so this is the equation for magnetic flux. You get B, also called flux density, which is equal to the magnetic flux divided by the area. So if you have a larger area, you have the lines of flux more spread out, so the flux density is less. If the area is small, you have a greater flux density because the lines are closer together. Okay.